Now if the computer don't go haywire, I'll have this video for y'all up. Now get your handouts out. The ones that I gave you yesterday. If you don't have one, they're in my office and you can get one later, so I'm not going to worry about it. I don't have... Where's my stylus? Somebody stole the stylus. They probably stole them with my dadgum keys. Let me go get those handouts and I'll get a... I think there's a stylus in my... It's broken, but I can use it.
Don't let your keys go.
Does everybody have a handout? Everybody got them the other day? All right. Now, the second part of graphing is how to graph. Now, a lot of you probably say, oh, I know how to graph. I did it back in pre-algebra. Yeah. A lot of people know how to graph the pre-algebra way, and that is the chart plot method, which is method 1. Method 1 is the chart plot method. And I call it chart plot. That's not what it's called in mathematics. It's called graph using the coordinates, or graph using the ordered pairs, or graph using points. That's what it's called. So you might need to go out to the side, out over in here, and you need to write those down. Graph using coordinates, graph using points, and graph using ordered pairs. Because if you see the directions and they say one of those three, that means you're going to be using the chart plot method. Get your highlighter out because I'm going to write something in red here. Graph using points, coordinates, or ordered pairs. Just write those 3 words down. Points, coordinates, or ordered pairs. And what I'm going to write in red is you use this method when y is by itself. A lot of people say, well, I can get y by itself. Well, if y is not by itself, you're going to use method 2, which we're going to talk about when we get to method 2. So that's what you need to highlight right there because that's very important. So, what do you do first? The first thing you do is you draw because y is already by itself, so you don't have to worry about it. First thing you do is you draw a chart with x and y as so. And then, number 2, you pick points for x. Now, 90% of the time, I'm going to pick these 5 points, -2, -1, 0, 1, and 2. Why do I pick those 5 points? Why don't I pick -100, -50, 0, 150, or 50 and 100? Why do I pick those points? Okay. They say I'm loud. Why am I going to pick these points? Huh? Easy math, because they're so what? Small. What else? There's another reason. There's 3 or 4 reasons I picked those 5 points. 1, small numbers, meaning easy math. What else? That means y'all can take a guess. It's not rhetorical. I'm asking y'all a question. Why do I pick those points? They're easily to do. Well, like you said, they're small, so they're easy to do. So you're right, but that's one. What did you say? Somebody said something. Easy. They're easy. That's still 1. There's another reason.
They're even numbers?
No, they're not even. They're close to 0. So you're getting the left side of the origin, and you're getting the right side of the origin. Why do I pick 5 points? Why don't I just use 2? 2 points make up a line. Why do I pick 5? Because I want you to work more? No. Because 2 points make up a line. How many does it take to mess up those 2 points? It only takes 1 point to get it wrong. If you plot one of those points wrong out of the 2, then you got the wrong answer. 5, you're ensuring that you're not messing up 1 point by the other 4 lining up. What's about the other 10% of the time? The other 10% of the time, I'm going to use multiples of denominator. Well, what does denominator mean? That means we've got what in the equation? A fraction, Hubert. That's right, class. 3. Plug and what? Plug and chug. Plug in the numbers that you pick in for x and get what? Y. 4. Plot points. And when you plot the points, what do you think it's going to form? A line. Unless you don't know what you're doing. So let's go ahead and do, and you don't have to write any of this down, because where is it? It's on the handout. So let's pick you've got one example on your paper, on your handout, so let's go ahead and do another example. Let's do, well, first of all, before we do examples, let's do a fraction sheet. I want you to take out a sheet of paper, and I want you to divide it into 10, 12 sections like this. Many as you want to. Just turn it on its side and draw about 12 sections there. The first section, y is equal to 1/2 x plus blank. And draw an x and a y like that. Second one, y is equal to 1/3 x plus blank. X and y. Y is equal to 1/4 x plus blank. Y is equal to 1/5 x plus blank. Y is equal to 1/6 x plus blank. And I want you to fill it out as 7, 1/7, 1/8, 1/9, 1/10. Y is equal to 1/11, x plus blank. Y is equal to 1/12x plus blank. Y is equal to 1/13x plus blank. And I'm not going to fill out all of them. I'm just going to do these and do the last three. You can fill in the middle. All right, somebody tell me what points I'm going to pick for x on this one. Multiples of the denominator. What's the denominator? 2. So that'd be -4, -2, 0, 2, and 4. Here, what's 3? -6, -3, 3. Thanks for the interaction. I appreciate that. Whoever that was. Thank you. What about 4? That means somebody else. 16. Not 16. Drop down 4, or a couple of 4s. Negative what? 8?
-8, yeah.
-4, 0, 4, and 8. How about 5? -10, -5. How about 6?
-12.
-6, 0, 6, and 12. All right, fill out the rest of them. I'm not going to do them, but this one will be y is equal to 1/7 x plus blank. Y is equal to 1/8 x plus blank. Y is equal to 1/9 x plus blank. Y is equal to 1/10 x plus blank. Now we'll go ahead and do them all. What's 7? -14, -7, 0, 7, and what? 14. What about 8? -16. Y'all all don't jump at the chance to answer, okay? About 9. -18 and -9. 9 and 18. -10. I'm sorry, 10. -20, -10, 0, 10, 20. 11. -22, -11, 0, 11, 22. -24, -12, 0, 12, 24. -26, -13, 0, 13, 26. Now the reason I did this was whenever you have a fraction here, you use multiples of the denominator. Now, let's take one of these and let's make these are just blanks because it doesn't matter what's here. You just go multiples of the denominator. And what will happen to the fraction?
Cancel out.
It'll cancel out. 1/3 x plus 4. Now, there's a problem with a fraction in it, and we're going to graph it. What multiples are we going to use? -6, -3, 0, 3, and 6. So I'm going to go over here, plug and chug. 1/3 times blank plus 4. 1/3 times blank plus 4, 1/3 times blank plus 4, 1/3 times blank plus 4, 1/3 times blank plus 4. And we put a -6 over 1, -3 over 1, 0, 1 over, 3 over 1, sorry, and 6 over 1. And what happens to each of them? Well, 3 will go into -6 how many times? -2. -2 times 1 is -2, plus 4 is 2. What happens to 3 and -3? It makes a what? -1. -1 times 1 is -1, plus 4 is 3. What happens to the 0 times 1/3? It goes out to 0. What's 0 plus 4? And at this point, you can find your pattern. What are we doing? Adding what? 1. So 2, 3, 4, 5, and what? 6. Let's check the last one. What happens here? 3 will go into 6 how many times? What's 2 plus 4? That's right. And that's how you graph. That's how you graph using method 1 with a fraction. And you just plot it. I'm not going to go through the plotting too much because y'all should know how to do that. -6, 1, 2, 3, 4, 5, 6, +2. -3, +3. 0, 4. And 3, 5. And 6, 6. Something like that. Looks something like that. All right, let's try nerd. Y is equal to -1/2 x minus 2. All right, I'll let y'all do that one. What points we're going to use? -2, 0, 2, and 4. -1/2 times blank minus 2. 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 -4 over 1, -2 over 1, 0, 2 over 1, and 4 over 1. What happens with the -2 and the -4? The negatives cancel, and the 2 and the 4 cancels. 1 times 2 is what? What's 2 minus 2? There's your x-intercept. What happens to the negatives? They cancel. What's 2 and over 2? 1. And what's 1 minus 2? -1. That's right, class. What's 0 minus 2? -2. So now we see a pattern. 0, -1, -2. What's the next two going to be? -3 and -4. Let's check it. 2 cancels with this 2 times. That leaves -2. What's -2 minus 2? -4. And you plot that. -4 and 0. -2. -1. 0. -2. 2. -3. 4. -4. There's your line. Graphing's not hard. It's how it's presented makes it hard. So that's method 1. Now I didn't do a whole number because your handout has a whole number. Y is equal to 2x plus 3. So with a whole number you pick -2, -1, 0, 1, and 2. So let's do method 2 now. Method 2 is called intercept method. In the intercept method, they'll have it in your book, graph using the x and y intercept. So out to the side, you need to put graph using x and y intercept. So that's what they'll have out in your directions. Graph using x and y intercept. Or graph using the intercepts. Method 2. And y is not by itself is in red. Now, a lot of people say, well, I don't care if y is by itself. I'll just solve for y. What are you eating up on the test, though? Time. Now, there are different ways to do different things in math. Why do we do that? To make students mad. That's why we do it. No, believe it or not, that's not why we do it. Why do you have a hammer and why do you have screwdrivers? Can't you just drive a screw into a piece of wood? Why can't you just take the hammer and hold it like a nail and drive the screw in a piece of wood? Why can't you just do that? Anybody know why? Y'all don't know why, do you? Huh? It ain't going to work. Why? If you drive a screw, here's what a screw looks like, okay? It looks, I'm going to exaggerate it a little bit. It looks like a nail, doesn't it? But it has what? It has these metal what? Threads, and they're raised, right? Like that. In other words, they're wider than the actual screw, aren't they? Because they go out a little bit. So if you take that screw and you drive it in this piece of wood right here, even though the screw is shaped like this, how big is the actual hole going to be that you drive this into? It's going to be about this. Why is it going to be bigger? Because the threads stick out a little bit here and a little bit here. So if you drive that screw into a piece of wood and the threads are cutting out a hole that's the same size as the threads in the screw, what's going to happen when something pulls on that screw? It's going to what? It's just going to come out because there's nothing holding it. The whole purpose for the threads is for when you take a screwdriver or an electric screwdriver, that does away with, well, does away with that dotted line, and then that screw just augers itself into the wood And what keeps it from being pulled out? Those threads are digging into the sides of the wood. If you just take a hammer and beat it down, it's pushing that wood away, and when you pull on that screw, it's just going to come right out. Now, what's that got to do with this? That's why you use a screwdriver instead of a hammer. Because you're wasting your time if you use a hammer, even though it's quicker. Solving for y takes up time. So use method 2 whenever you don't have y by itself. All right? That's why I tell you. Same thing with, why don't you take a hammer and put a, I use the hammer because everybody knows what a hammer looks like. Why don't you use a hammer, put a cloth on it, tape it to a rod, clean the windows. Why don't you do that? Because if you accidentally hit the hammer up against the glass too hard, what's it going to do? Then why don't you use the hammer? You can, but why do you not use it? Because you don't want to break. You don't use a hammer for everything in the house. You don't use method 1 for every single problem that you do with graphing. But y'all believe that y'all can. And the person that believes that is on number 10 when everybody else is finishing the test. Because they're doing it their way. And if you also do it your way, it will mark it wrong even if you got the answer correct. Why? Because this one is looking for 2 points. And what are those points? The intercept. If you don't plot those 2 points on the test, and if you don't plot those 2 points on the homework, even though the line is identical, it's going to be wrong. And I'm not going to count it right because you didn't follow what? You didn't follow the directions. And the directions say graph using the intercepts. So don't get all crazy on me if you get it wrong and you look at your answer and your answer is exactly the same as the other answer. You just didn't follow directions. You did it your way. First thing to do, draw a large table. Not a table that you sit at. That's not what I'm talking about. A while ago we drew a little chart. A table is a bigger version of that you can actually put an equation in. So I'm going to draw a big table like this where you can put an equation on each side. And this is all on your handout, so just follow along on your handout. And on this side, I'm going to put x-intercept, 0 for y. And on this side, I'm going to put y-intercept, 0 for what? X, Hubert. Yeah, it's always the opposite. Well, x-intercept, 0 for y. Y-intercept, 0 for x. Now, this is the concept right here that I'm trying to teach you. I'm not trying to do this because it's making you work extra. I'm not doing it because it's making you take extra time. I'm trying to teach you that in business, in marketing, in trig, in calculus, in physics, in biology, in any math-based course, accounting, if you want to find the x-intercept of your graph, you're sitting in a meeting and you got a graph that looks like this or whatever, and you want to find where it crosses that line right there, you're going to plug in 0 for what? Y. Or 0 for x, whatever the case may be. 0 for x, for the y-intercept. And if you want to find where it crosses, if you got another line coming down through here, and you want to find out where this line crosses, and this is a business presentation, you plug in 0 for what? X. So what I'm trying to teach you right here is not making a long way shorter, making a short way longer, making you mad, making you miss the problem. No, it's not all about you, okay? The reason I'm showing you this is because you need to remember to find the x-intercept in any application, you plug in 0 for y. To find the y-intercept in any application, you plug in 0 for what? X. And that's what you need to memorize out of this section, out of this method. So, I'm going to give you an example of one so I can just show you. It's better to give you an example. 3x plus 6y is equal to 12. There's our equation. Now the second thing you do, after you draw the table and put in your x-intercept and y-intercept, the second thing you do is you put equation in and line up 0. What is 0 here? Y. So I want my y to be right up under this 0. So here we go. 3x plus 6y is equal to 12. What is this 0? So I'm going to do 3x plus 6y is equal to 12. And I'm going to draw an arrow right there. And I'm going to draw an arrow right there. Now there is a much shorter way of doing this. If you've done this before, or you have had a class in this before, you know just to cover up the term and it'll go away. And that comes later after you learn how to do this. All right, there is a faster way of doing it, but everybody's got to crawl before they can what? Walk. What does that 0 do to this y term? Cancels out. You get 3x is equal to 12. X is equal to what? 4. And that 4 goes where? What happens to this? What does this 0 do to the x term? Cancels it out. You get 6y is equal to 12. Y is equal to what? 2. And that 2. And then plot those 2 points and you got your line. Now, why does Hubert put x-intercept here and y-intercept here? Why don't I just do away with those words and just add 4, 0 and 0, 2? Why do I put that there and this here?
Because you're going to, the 0 stands for the opposite of where x is.
Yeah, that's a good guess, but that's not why I do it. Now, I'm not talking about why. This is a Hubertism. You ain't going to see this in a book. You might see it written here and here, but you're not going to see it written like this because this is the way that I teach it. It's the way I learned it as a student. Why do I put x-inter up there and y-inter right there? Because of the number one reason that students miss this problem. Does anybody want to take a guess at what's the number one reason students miss this problem?
Let you know what you're solving for.
You're getting there. They what? They graph the wrong point. They'll put the x-intercept on the y-axis and the y-axis on the y-intercept on the x-axis. They've done 90% of the problem correct, but how much are they going to get wrong? They're going to get 100% of the problem wrong because they graphed the wrong line. That's why I put x-inter right there and y-inter right there. Same reason I put parentheses when I plug in. I still do that as a teacher, as a student, whatever. And if I plug in something, I'm going to put parentheses. Although some students don't have to do that. Some students don't have to put x-intercept and y-intercept there. But watch what happens when they are pressed for time. That's going to be the first thing they do is plot the wrong point. Okay? And that's method 3. Method 2. It's pretty. One thing about method 2 is it's the quickest and the easiest and the simplest or whatever. But it's the most prone to make a what? Mistake. And that mistake is plotting the wrong point. Now, method 3. Method 3 is what I call building a line. what do you need to write out to the side? What you need to write out to the side is plotting or graphing using the slope and y-intercept. That's what you need to write. Using the slope and y-intercept, because that's what they're going to call it. Now, I tell students that this method is good for two reasons. When y is by itself, but it's the best one to use when you have fractions for the slope. Now, in method 1, I told you to write multiples of the denominator when you had a fraction. And yes, you can use method 1 and method 3 interchangeably. But the quickest way to do a graph, to graph a line, when y is by itself and there's a fraction, is method 3. What do? Well, first thing you do, extract info. What does the word extract mean?
Take out, yeah.
Extract the tooth. What does that mean?
Take out.
Take it out. All right, so what I want to do is I want to extract info from y equals mx plus b. In other words, I'm going to give you an example here in just a minute. And what are you going to extract? 1, or A, you're going to extract the y-intercept. And you're going to write it 0, comma, b. Because y-intercept, what is always 0? X. We just learned that in method 2. B, direction of the slope. Either it's going to be positive, which means left to right up, or it's going to be negative, which means what? Left to right down. How many sides of a hill are there? What are they? Uphill and what? Downhill. It all depends on which direction you're coming from. C is M written as vertical over what? Horizontal. Now, what do you do after you find out all that information? That's easy. All you got to do is look at it and you find all that information. What do you do with it? Well, the second thing you do is plot the y-intercept. This is not supposed to all be in here like that. Plot the y-intercept. 3. Draw a trace line. Now, what is a trace line? A trace line is a real thin pencil line, and it's going to be going left to right up, or what? Left to right down. That's it. And I'll show you how to do that. And then, number 4, from the y-intercept, build using vertical over horizontal. Now all this is on your sheet, so you don't have to rewrite it. It should be all on there. It may be in a different order, but it's the same concept. So let's look at one. Y is equal to 2/3 x plus 2. Now what I'm going to do here is I'm going to use my different colored highlighters and I'm going to pull out my information. A, B, and C. Alright, A. 0, comma, blank. And I'm going to take my highlighter and I'm going to highlight it yellow. And there is my B, which I'm going to put right here. So that's that. Now, my direction of my slope, I'm going to highlight that green. And I'm just going to highlight that area in front of that 2/3. What is that area in front of that 2/3 if nothing is there? Is it positive or is it negative? It's positive. So I'm going to put a dash positive right here because it's not there. It's like a cross, but you can, oh my gosh, I'm trying to convert people. ACLU. It's a plus. All right, so what does that mean? Left to right, what? Up. And then I'm going to take my blue highlighter and I'm going to highlight this right here. And that 2/3 is my vertical over my what? Vertical over horizontal. Okay, I'm going to move all that over a little bit so everybody can still see it. Everybody got that? So that's pretty simple, isn't it? And like I say, you can do that just by looking at this. So you draw your graph. Now I'm going to put my grid up here because on a method 3, you need to have a piece of graph paper because you're going to need it. So, well, actually, you need it on all of these, but some of y'all, I could talk till I'm blue in my face, and y'all wouldn't get graph paper. Y'all don't need it for some reason. But anyway, I'm talking about the students in general, not y'all personally. All right, there's my graph. Now, what's my first thing I do? Plot the what? Y-intercept. So I'm going to take a yellow marker and I'm going to put my y-intercept at 0, 2. There it is. Now, that's done. I'm going to mark that out. Second thing I'm going to do is I'm going to draw my trace line. What the heck is a trace line? Well, I'm going to show you. You take your handy dandy green pen and we'll make it straight just for y'all. Real light. You can barely see it. And I just draw it. Did y'all see me measure anything? Or did y'all see me count or anything? Or did y'all just go left to right up? Left to right up. Well, here, how do you know it's left to right up? Put your car right here. What's that car doing? What's that car going to do if it goes from left to right? What's it going to do? It's going uphill. Left to right up is uphill. Now, I know it's hard to see that green line, but there's a green line there, and it's going left to right uphill. Now, mine's about at a 45-degree angle. See, 1 to 1, that's almost a 45-degree angle, but it's not. In other words, I just sketched it up there. I could do it. I'm going to make it a little bit darker for people at home. Hold on. Well, so much for dark green. Well, I've tried. That's even worse. I wanted to get a dang old hunter green or something. Let's try this olive drab. Look at there. I didn't even draw a straight line that time. I could draw it like that. I could draw it like this. I could draw it like this. Doesn't matter. Trace line's done. Now, 2 over 3, where do I start from? Well, where's the only point there is that we plotted? What's the only point that we plotted? The yellow one. The yellow one. So that's where we're going to start from. I'm going to take my my blue marker. That's a little bit bigger now. And I'm going to plot 2 up and 3 over, or 2 down and 3 over. It doesn't matter. Vertical means what? Up or what? Down. Horizontal means left or what? Well, what tells you where to go? The trace line. I'm going to go down, just piss y'all off. I'm going to go down because I know there's somebody out there that says, oh, it's positive. That means you got to go up. You don't know what you're doing. That 2 means vertical. That 3 means horizontal. It don't matter which way as long as you go with the trace line. Let me show you what I'm talking about. How many am I going to go down? 2. So I'm going to go down 2. Where's the trace line? Is there a trace line over here or is there a trace line over here?
On the left side.
That's where I'm going. So how many do I go over? 3. 1, 2, 3. And there's my dot. 1 down, or 2 down, 3 over. 1, 2, 3. And let's say you don't want to go down. Let's say you want to go up. You go back to your Y, go up 2. Where's your trace line? And ain't one over here. Where is it? It's over here. So you go over 1, 2, 3. Up 2, 1, 2, 3. And you're done. All you got to do now is just draw a line. Mine's a little bit off, but I'll fix it. Hold on. If it'll let me. That's good. Unless I won't let me move it. Where's my... Dummy. I give up. Over here. There it is. There, just close enough if it doesn't work. Y'all see it. Now what I do after I draw my blue line, do I need my green line anymore? No, you can pretty much erase it because all it was to show you where to plot your what? Plot your points. That's it. Now let's do another one. This time let's put a negative in front of it so y'all can have a feel. Let's do a negative. Y is equal to negative 1/3 x plus 4. All right, I'm going to let y'all do that one. Oh man, I ever have a day with this? Oh no. Let's do yellow. That's what happened. Green. And blue. All right, what is my y-intercept? What is my slope? Is it negative or positive? That means it's going left to right, what? Just like that. And what is my slope? 1 over what? Which is my vertical over my horizontal. Now this when some of the program students, they get all crazy. They go, oh my God, you can't do that. The slope is negative 1/3. No, it's not. The slope is 1/3. That means for every 3 that you go horizontally, you go up 1. I don't care if you work for the state or if you work for marketing, the slope is 1 over 3. The direction of the slope is negative. And in the State Highway Department, what's negative slope mean? You're going downhill. And that's what they put on the sign, negative grade, meaning you better gear down because you're going to go what? You're going downhill. So, 1 over 3 is your vertical, and the program students, they just have fits over that. All right. Some teacher got a hold of them and said, you cannot go, you have to put -1 over 3. Oh, it makes me mad. All it does is confuse students. Oops, that's wrong. Black. Think that's thick enough? Good gracious. Y'all ain't gonna say anything anyway, so. All right, what is my y-intercept is 0, 4. 1, 2, 3, 4. So there's my y-intercept. Make it a little bit bigger so everybody can see it. And trace line, I'm going to make it green. And it's going to be, I'll make it straight. And that's a little bit bigger than I want it, so I'm not going to do that. Oh yeah, thank you. Left to right down, be going this way. Notice I just drew it. It's not even going to the y-intercept. The only thing it's telling you is left to right down. How do you know it's left to right down? Well, which way do we read? Here's your car. Which way your car going? Downhill. Leave my car alone. You want to draw a car, you come up here and draw it. But you have to teach class if you're going to draw it. Alright. So, one what?
Is it class canceled?
1 vertically, 3 horizontal. So, just to piss off the program students that believe I have to go down because it's negative, I'm going to go up. So, I'm going to go up 1. Where is my trace line? To the left, so that's where I go. 1, 2, 3. Let me make sure I do my lines. I'm going to do it. So 1, 1, 2, 3. 1, 1, 2, 3. 1 down. 1, 2, 3. 1 down. And there's your line. Take your blue line. And we're going to graph it. And there's your line. And once you get through with that line, what do you do to your trace line? You delete it. And there's your line. Now how hard is that? Yeah, extremely difficult. I'd quit.
Good thing today's the last day I can withdraw.
There's what?
That's a good thing today's the last day I can withdraw.
Oh, you gonna quit on me? Good. The more people I can get to quit, the better the more money I get paid. No, I'm just kidding. That's a joke. That's it. How you feel? You feel good? Well, I got to do something to discourage you. Homework. You know the difference between being hungry and hungry. When you hungry, that means you can eat a good bit. All right, I want to show you one more thing. And this is parallel and perpendicular lines. Huh? What? Oh, magic. Parallel and perpendicular lines. Now the way this is going to be asked is they're going to give you directions. I can't get it back on the board. This is the hardest thing in the world to do is get this thing on the board. All right, they're going to say find an equation for a parallel or perpendicular. It'll ask for one, but I'm going to show you both. For a parallel or perpendicular line with the equation y is equal to 2x plus 3 going through the point 4, 6. Now, you need to make a note. It's going to ask you for one. So it may say, find an equation for a parallel line with this line at the point 4 and 6. Or it may say, find an equation for a what? Perpendicular line with this line at 4 and 6. It's not going to ask you for both. I'm going to show you both at one time, kill two birds with one stone. And the way I would suggest you practice it at home is do it this way and then pick whatever you need. So draw a big table with 3 columns. Big table, 3 columns. I can't get this thing back on the right number. All right, over here, you're just going to put the equation. Y is equal to 2x plus 3. And right here, solve for y if needed. Okay, you don't need to right now because y is what? Already by itself. So if they give you 2x plus 4, y is equal to 6, then you need to solve for y in this left column over here. And here, m, what is m equal to? M is equal to what? 2. Now, do you remember the rules I gave you Monday about parallel and perpendicular lines? What were they? M sub 1 is equal to m sub 2 for a parallel line. And m sub 1 times m sub 2 is equal to what? Negative 1 for a perpendicular line. So right up here, I'm going to write in blue. I'm going to do my parallel line first. And I'm going to use the point 4 and 6. And I'm going to write down here m sub 2. This is m sub 1 right here. So if m sub 1 is equal to 2, and I want a parallel line, what is m sub 2 going to equal? So that would be what?
0. No,
2.
2. Oh, yeah, okay.
Because this is m sub 1. Let me just write a m sub 1 right here. Okay, so that's why, therefore, m sub 1 is equal to 2. Therefore, m sub 2 is equal to 2 because of this rule. Parallel lines, or the slopes are what? Equal. Now, what do we have here? We have a point and a what? What do you use if you're given a point and a slope? Point-slope equation. Y. Oops. Y minus y sub 1 is equal to m times x minus x sub 1. And what is this? X sub 1 and y sub 1. Plug and chug. Y minus 6 is equal to 2 times x minus 4. And now what? Solve for what? Solve for y, Hubert. That's right, class. Solve for y. Y minus 6 is equal to 2x minus what? And y is equal to 2x plus negative 8 plus 6. And that is your equation for what line? Parallel line to this line. Now I want you to do the perpendicular. And we'll do it in red. So that means you're going to do a perpendicular line. And it's going to go through the point 4, 6. And m sub 2 is equal to what? Now remember, for a perpendicular line, what does m sub 1 times m sub 2 have to equal? So that means it's got to be the opposite sign and the reciprocal. So what's the opposite sign and reciprocal of 2? Negative. Reciprocal of 2 is what? 1 over 2. So that'd be negative 1/2. Opposite reciprocal. So you need to highlight this thing right here for perpendicular and put opposite sign, reciprocal. You need to highlight that. Opposite sign and reciprocal of m sub 1. And what do we have over here? We have a point and a what? Slope. Y minus 6 is equal to negative 1/2 times x minus 4. Y minus 6 is equal to negative 1/2 x. And what's negative 1/2 times negative 4? Plus 2. And y is equal to negative 1/2 x plus 2 plus 6. And that line is what to these two lines? What? This line is perpendicular to the blue line as well as the black line that we started with. Now, they will only ask you for either the blue equation right here or they will ask you for this one. What I tell students to do to get extra practice is whenever you are doing these type questions, make sure that you do both and then just pick out the one that you need. And that way you get extra practice and you get the right answer. And that's 6.7, or whatever chapter we in, 7. Is it chapter 6? So, let's talk about what we're going to do now. Well, we're going to go ahead and get some tests loaded. Don't y'all think? So y'all can be working on them. Because I know how studious y'all are. And here we go. Import. I'm going to fix y'all up. Let's see. This class is at what time? 12:45. I think it's not even in here. Good. I can just pick one that was, let's see, last semester. I think it was at 12:30. Let's see if that will work. Yes. Yeah. There y'all is. Now let's look at it before I assign it. Let's see, edit. Six point one, 6.2, 6.2, 6.3. Take those off and put new ones in its place. These off. 6.6, 6.5. There ain't enough questions on there. We need to put some more questions on there. All right, show custom questions. There they are. And let's see. Yep, we need to change that one. I ain't gonna change it right now. I'll change it later. Add. I'm gonna skip that one and add another one. Add that one. And skip that one. That one. That one's messed up. That one. That one. That one. That one. That one. That one. And that one. Means that give you now, let's see, close. It gives you 24 questions, so you should be all right on that. Save and assign. Okay, whatever. Yeah. And let's go ahead and fix the due date for both of them. Well, I got to check this one right quick too. Let me check it. Make sure there's harder questions on there for you. Let's see, this is unit 2. Next. Make sure the easy questions are on there. I don't see them. Oh my, they're not on there. Guess we're going to have to fix that. How many questions? 15? Alright, I'll put, I can't remember which one's which. Let's see, add, next, add, next, add, next, add, next, add, next, add. How many is that? 26. Alrighty, so let me save that one. And then we'll look at the homework and give y'all something to complain about, and dead grandmothers and all that stuff that's going to happen between now and then. So we'll go ahead and do this first. Change dates, and we will make Unit 2. Let's see, we'll make this one, today is what? October 15th. We'll make it 1 week. October 22nd. And we'll change that to 11:59. Oops, wrong one. 11:59 p.m. and we'll make this one the 15th, October 15th, and we'll open it up for October. Give y'all till that Monday to finish that one. And that'll be 11:59. And then we'll talk about the homework so you'll all know when that's due. Update changes. Alright, those are done. Now homework 6.1, 6.1, 6.2, 6.3, 6.4, 6.5, 6.6 and 6.7. And October 27th, I'll make it due. And any questions? That fair enough?
So you need to tell me, I was up at 3 o'clock in the morning, Monday night, doing every last one of my homework assignments, after I had work since 7 o'clock in the morning, was in K. And I had 2 weeks.
I just felt like I'd give y'all a little bit of extra time. I didn't know you busted
That
your
ain't
rear
what you
end.
said Monday, you said.
Okay, I'll change it then.
Tuesday.
No, I've already put it on there. Well, you ain't got to worry about it. All you got to do now is worry about the test. Okay, so the tests are due on the what?
22nd and 27th.
22nd and the 27th. When is the homework due?
The 27th.
Okay. So
When's it due?
I believe y'all just like to ask that, just to ask it.